This video is going to go over 1-3 piecewise defined functions. We're going to be doing a few different things with these, but mainly we're going to focus on graphing piecewise functions from an equation and writing the equation based on a graph that's given. So first we have our essential question: how do you model a situation in which a function behaves differently over different parts of its domain? So piecewise functions are going to have different rules depending on what x values you're looking at. We're actually going to skip this example. This is in the PDF of the notes that are uploaded into Schoology, but for right now, I'm just going to skip over that. So now we have our definition, very close to what we had in the essential question. So your piecewise defined function is some function that has different rules for different parts of its domain. So now we actually have the graph of a piecewise function, and I may need to scroll to give you guys a little bit better of a view of this for the different values that we get. We need to graph our piecewise defined function. We're going to state the domain and range and the intervals that it's increasing and decreasing. We have three separate pieces here. So we have this top piece, we have the middle piece, and we have the bottom piece. And you first want to look at your pieces and decide whether they are linear, quadratic, absolute value, or something else. So the very top piece of my function, and this is rather than writing f of x out 3 times, we have it written once and it goes with each of these equations. So my top piece, 4x plus 11, that is in mx plus b form, which means the top piece is linear. To graph a linear equation, all you need is 2 points. So we're actually going to be using these boundary marks, these domain marks for x, to graph that one. The middle piece has a square in it, so this piece is quadratic. So it is going to be that U shape that you have. We want to identify our h and k whenever we graph that one in order to get a good picture. And then the last one that we have, x plus 1, this is also a linear because it is in mx plus b. So now back to the top piece. This piece is contained between the x values of -10 and -2, which means we are going to be starting at the x value of -10 and we're going to be ending at the x value of -2. Now to set up my graph here, I'm just going to scroll down a little bit to give myself a little bit more space. I'm going to wait to set up my scale until I actually see what I have here for my values. You want to look at your inequalities to see if they have lines under them to determine whether your dots are going to be open or closed at those endpoints. Everything in between is understood to be closed, but at the endpoints you have to be careful because it can change. If there's a line under the inequality, that means that your dot is going to be closed. If there is no line under the inequality, that means that your dot is going to be open. So that means whenever I plot my value that I get when I plug -10 in, that dot is going to be closed. Whenever I plot the dot, whenever I have the -2, that dot is going to be open. So let's go ahead and plug these in. If we plug in -10, I have 4 times -10 plus 11. That's going to give us -29. That dot is closed because the -10 has the equal sign under it. Then I want to plug in the -2. 4 times -2 plus 11 is 3. That dot is going to be open because the -2 does not have the line under the inequality. So let's go ahead and set up our graph. I do need to go the whole way down to -29, so I'm going to let each block represent 3 on the y-axis. On the x-axis, I'm going to have each block represent 2. So we have 2, -2, -4, -6, -8, and there would be -12. So -10 will be in between there. And then I'll go the other direction as well. Going down my y-axis, I'm going to count by 3s. So I have -3, -6, -9, -12, -15, -18, -21, -24, -27, -30. And then I'll do the same thing going up as well. So now I'm going to plot those two dots. So I have the point -10, -29, which is going to put me about right here. And then the point -2, 3, which is going to be right there. And then I'm going to be connecting those. Notice the -2, -3 point, that is an open dot. Next I have the red quadratic piece. The quadratic piece, we want to identify our vertex, that would be the H and K. Notice that there's no parentheses with the square, so that means that our H value is 0. Because to have an H, you have X plus or X minus something in parentheses with the square outside. And there's no parentheses, so your H is 0. 0 is in the domain here, because 0 falls between -2 and 2. So that means I can use my vertex value as one of the points that I plot. The K value is -1. That's going to be the ordered pair with your H. So 0, -1, that's going to be one of the points that we plot. And I'm actually going to go ahead and put that on our graph. And again, it's in between the boundaries, so it's automatically going to be closed. It's always a good idea to have 2 additional values, one on each side of the vertex when you're graphing a quadratic. And for this one, the other 2 boundary points, the -2 and the 2 for the X, one is less than 0 and one is greater than 0. So those are the other points that I'm actually going to use in the problem. Both of those have lines under them, so both of those are going to be closed. When we plug in -2 for the X, -2 squared minus 1 is 3. And +2, which I realize I just wrote a -2 twice. See if I can click on that. Let's try this one. Okay, so we have +2 squared minus 1 is also 3. So -2, 3, that's a closed dot. That actually happens over top of my open dot. When you have a closed dot over top of an open dot, it's by default going to be a closed dot. It's going to fill that dot in. My other dot is at 2, 3, and so that's going to be right there. And then I would connect them. Remember, the parabola, the quadratic, it is that U shape, so you want to make sure you smooth that out as much as possible. Lastly, then, we have this linear piece at the bottom. And again, I have boundary points, so I'm going to use both of those. The 2 is actually going to be open, and the 10 is going to be closed. When I plug in 2, 2 plus 1 is 3. Remember, that's open. When I plug in the 10, 10 plus 1 is 11. That one is going to be closed. You want to make sure you do not have 2 closed dots above each other. That's something that should not happen whenever you're doing these types of questions. So 2, 3, putting an open dot over top of a closed dot is technically still going to be closed. Just be aware of that. And then I have the point 10, 11, which is going to be about right there. And then I would connect those 2. And then we have a couple of other things they're asking about in the question. So they want to know, what is the domain and range, and over what interval is it increasing or decreasing? Your domain is going to be all of your X values. We start at -10, we end at 10, and we don't skip anything in between. So my domain is -10 to 10. My range is going to be the lowest to the highest Y value. The lowest Y value that I go down to is -29. The highest Y value we go up to is 11, and we don't skip anything in between. Now I want to look and see where I'm increasing. Well, I start increasing from an X value of -10 the whole way until X is equal to -2. I also increase from 0 up to 10. Even though it's increasing and then it's increasing at a different rate, it is still increasing everywhere from 0 to 10. Decreasing then, we are decreasing where it's not increasing in this case. That would be -2 to 0. So this was a basic introduction on how to graph a piecewise function. There will be a different video for how to write an equation of a piecewise function when you are given a graph. Please let me know if you have any questions. We'll be practicing this over the next couple of days.